Hello my dear students. In this video you are going to learn what is a great cycle and how you can find or calculate the distance between 2 points on a great cycle. Great cycle is a cycle that is bigger than any other cycle. The cycle is either all longitudes. So longitude is a great cycle. Nobody can draw a cycle bigger than longitude no matter whatever compass that you are using. And equator is another great cycle. Equator, remember, is a special latitude that is 0-degree latitude. So they are called great cycle because there is no any other cycle bigger than those cycles. Great cycles have radius equals to radius of the earth. So all great cycles, their radius is exactly equals to radius of the earth, which is usually given in the question. We'll take an example. Next we learn is how we can calculate the distance between 2 points that are on the great cycle. So suppose 2 points x and y are on the same longitude. If the 2 points x and y have common longitudes and we want to find the distance between them on the earth's surface, so there we may have different cases. Let us see the cases. Case 1 we consider is when the 2 points are in the opposite hemispheres, meaning one point is in the northern hemisphere and the other one is in the southern hemisphere. What we do first is to sketch our earth and try to mark these two positions. So this is the cycle that represents the earth. So starting with the common longitude of x and y, look at the common longitude, look at it. So x and y that are on latitude alpha degree north and beta degree south respectively, for example, meaning they are in the opposite hemispheres. Now let us draw the latitude alpha degree north for x. Look at the latitude alpha degree north. You can see it in the northern hemisphere. And let us draw the beta degree south, the latitude beta degree south. Look at it now. I am drawing it. You can see beta degree south. That is the position of x and y. You can mark x and y. Now the distance between these 2 points is nothing but the length of this arc. Look at the arc that joined x and y along that common longitude, because that longitude is a cycle. So distance between x and y will now be length of an arc. And that arc obtain an angle theta at the center of the earth. Look at it. Look at the angle theta. And remember we said longitude have radius equals to radius of the earth. So the radius of that cycle, you cut the radius, is marked by capital letter R. So there what we needed to do, the distance between these 2 points x and y will now be nothing but the length of arc xy. The length of arc xy, we have learned how to find the length of arc in our previous lesson. So length xy will now be the length of the arc xy. Now the distance xy, which is the length of that arc, is given by the formula, remember, theta over 360 multiplied by 2 pi r, where r is the radius of that cycle and this cycle is longitude and it is radius equals to radius of the earth. So that is why we use the capital letter R. But how do we get the theta? That is what we need to know in this case. We use same formula, but how we can get the theta is differ from case to case. So in case 1, how we get the theta is angle subtended by the arc xy at the center of that longitude. How we can get the theta? What we just do, we added the latitudes. So theta would now be equals to alpha plus beta, because the two are in the opposite hemispheres. So you added the two angles to get the theta. And you can see it also in the drawing. But the radius of the earth equals to, the radius of that cycle is equals to radius of the earth. And the pi is given is 22/7. Or you can equally use 3.142. Depending on what is given in the question, make sure you use it. We'll take examples. Another case, the same 2 points x and y that are on the same longitude, but another case is case 2. Case 2 happens when the 2 points x and y are on latitudes alpha north and the beta north, which means they're in the same hemisphere, either northern hemisphere or southern hemisphere. So let us draw it. We make the sketch of the earth. We make a common longitude. Look at the common longitude. and we mark the latitudes alpha north and beta north. Look at the two latitudes, and we mark the position of the x and y. So x is on latitude alpha degree north and y is on latitude beta degree north. The distance between x and y on the earth's surface will now be given by the length of the arc xy. Look at the arc that joined x and y along that common longitude, because that longitude is a cycle. So distance between x and y will now be length of an arc. And that arc obtained an angle theta at the center of the earth. Look at it. Look at the angle theta. And distance xy is given by the formula theta over 360 multiplied by 2 pi r, where r is the radius of that longitude and it is the something as radius of the earth. And the theta, how we can get the theta now is what we need to know if we are in case 2. Case 2 says the 2 points are on the same hemisphere, meaning either north hemisphere or south hemisphere. So to get the theta, what we need to do is to subtract the higher latitude minus the lower latitude. So in this case, the higher latitude is alpha because it's above beta north. So subtracting beta north from alpha north, that will give you the theta, the angle subtended at the center of that longitude. Pi is given as 22 over 7 or 3.142. So whichever one given, make sure you use it. We also take example of this case 2. The last case is case 3. Case 3 says the 2 points are on the equator. Remember, equator is another spatial longitude. So suppose 2 points x and y are on the equator, and the longitude of x is alpha degree east and the longitude of y is beta degree west. So let us sketch it. This is the cycle representing the earth. Look at the common latitude, which is the equator 0 degree latitude, and let us mark the longitude of x and the longitude of y. The longitude of x, it says, is alpha degree east. Look at the longitude alpha degree east. I mark now the position x, and I now draw the longitude beta degree west. Look at the longitude beta degree west. That is the position of y. The distance between x and y on the earth's surface will now be given by the length of the arc xy. Look at the arc that joined x and y along that equator, and that equator is a cycle. And that arc obtained an angle theta at the center of the earth. Look at it. Look at the angle theta. And that length of arc is given by the formula theta over 360 multiplied by 2 pi r, where r is the radius of that latitude, which is also radius of the earth. How we can get the theta now is next we learn. Is what we need to know in this case. The theta also, the angle subtended by the arc xy at the center of the equator, is now nothing but the alpha plus the beta, where alpha is the longitude of x, which is east, and the beta is the longitude of y, which is west. Why we added? Because the two longitudes are in the opposite direction. One is east, the other one is west. If it happens the two longitudes are in the same direction, maybe they are both east or both west, there we subtract the smaller latitude from the higher one. But as the two are in the opposite, so we add. That will give the angle subtended at the center. So capital R, radius equals to radius of the earth, and the pi is 22 over 7 or 3.142. Make sure you use the one given in the question. Starting with the example, it says 2 points x, which is 30 degree north, 50 degree east. That is the location of x. And another point y, its location is 10 degrees south and 50 degree east. These 2 points are on the earth's surface. The question asked here is to calculate the distance between x and y along the great cycle. Radius of the earth asked to use here is 6,400 kilometers, and the value of pi asked to use here is 3.142. This is a concrete question. So solution to this problem. What we do first is to sketch our Earth and try to mark these two positions. So this is the cycle that represents the Earth. So starting with the common longitude, look at the common longitude. The common longitude of X and Y is 50 degree east. So let me sketch the 50 degree east. This is longitude 50 degree east. Look at it, look at it, look at it. So I have now sketched my longitude 50 degree east. So I now move to the point X. X is on latitude 30 degree north. So let me draw my 30 degree north. Look at 30 degree north. Look at latitude 30 degree north. And that will be the position X where the latitude and the longitude crosses. That will be the point X. So next I'll move to the point Y. Point Y is on latitude 10 degrees south. Look at it in the question. So I will now try to draw my latitude 10 degrees south. Look at the latitude 10 degrees south. So that will be the point Y also, where the latitude 10 degrees south crosses the 50 degree east. That will be the point Y. So next, I will now try to get the distance between X and Y on the Earth's surface. The distance between point X and point Y. And that point is nothing but the length of arc. The distance is nothing but the length of arc XY. Let's see it. Look at the arc XY from X to Y. Is an arc of a cycle. And that arc obtains an angle theta. And the radius of that arc, the radius of that cycle, meaning the longitude, is capital letter R, which is the radius of the Earth. So this represents case 1. Case 1, remember, the 2 points X and Y are in the opposite hemispheres. One is north, the other one is south. So let us move. Well, we continue, we write the formula for finding length of arc, which is theta over 360 multiplied by 2 pi r, where r is capital letter R. So we now get the theta. Theta, remember, in case 1, what we needed to do, if the two are in the opposite hemispheres, we added their latitudes. So latitude 30 degree north and 10 degrees south. That 30 and 10 we add together to get the theta. The theta will be the angle subtended by that arc XY at the center of the longitude. So there I didn't correctly give us answer 40. So the value of theta that we use in this formula is now 40 degrees. That will be the angle subtended at the center. So there we substitute. Substituting, we now have the length XY. The length of the arc XY will now be given by 40 over 360. 40 is my theta. Multiplied by 2, multiplied by 3.142. That is the value of pi given in the question. And multiplied by 6,400 kilometers. That is the value of R. So we continue simplifying. Simplifying this correctly give answer 4,468.62 kilometers. That will be the distance between X and Y along the great cycle. Another example, it says 2 points A and B are both on longitude 100 degree west and have latitudes 80 degrees south and 35 degrees south respectively. The question asked here is to calculate the distance between A and B along a great cycle. The capital letter R given in this radius of the Earth is 6,400 kilometers, and the value of pi asked to use here is 22 over 7. Solution to that problem. Let us sketch the Earth and try to mark the position of those 2 points A and B. So this is the sketch of our Earth. And look at the question. The question says A and B are on longitude 100 degree west, so they have common longitudes. So let us draw this longitude. Look at the longitude 100 degree west. So look at the longitude 100 degree west. Look at it. Look at it. So the 2 points A and B will now be on this longitude, but on different latitudes. So starting with the point A. Point A is on latitude 80 degrees south. Look at 80 degrees south is highlighted in the question. So we try to draw this latitude. The latitude 80 degrees south will now be something like this. Look at it. So that will be the position A where the latitude 80 degrees south crosses the longitude 100 degree west. I now try to mark the position of B. B is on latitude 35 degrees south. Look at 35 degrees south is highlighted. So I try to draw this latitude 35 degrees south. Look at it. So, and look at the position of B. Position of B is where latitude 35 degrees south crosses the longitude 100 degree west. So next is to find the distance between the 2 points. The distance AB is nothing but the length of arc AB. Arc AB, look at arc AB. That arc is a part of this longitude. Look at it. The arc obtained an angle theta at the center of the longitude, which is center of the earth. And that arc AB, look at it. The longitude has radius capital letter R, which is equals to radius of the earth. So we now write the formula for finding length of arc AB, which is theta over 360 multiplied by 2 pi r. So next is to determine my theta. The theta here, look at the 2 points. The 2 points are on the same hemisphere, that is the southern hemisphere. So to get the theta, what we need to do is to subtract. Subtract the lower latitude from the higher latitude. The higher latitude is 80, while the lower is 35. So subtracting give us the theta. Theta is the angle subtended by that arc AB at the center of the earth. So subtracting 35 from 80 correctly gives answer 45 degrees. So 45 degrees is the value of theta that we needed to use in this formula. So there we can substitute to get the distance AB equals to 45 over 360 multiplied by 2, multiplied by 22 over 7, the value of pi given in the question, and multiplied by 6,400, the value of r given in the question. Simplifying this correctly gives answer 5,028.57 kilometers. That will be the distance between the point A and the point B along a great cycle. So another example. This question says X, which is on latitude 40 degrees south and longitude 50 degrees west, is a point on the Earth's surface, and Y is another point due north of X and is 4,000 kilometers away from it. The question asked here is to find the latitude of Y, but the value of R asked to use here is 6,400 kilometers, and the pi is 22 over 7. So let us see how we can answer this question. Solution to this problem: we try to sketch our Earth. Look at the cycle representing the Earth, and what we need to do now is to sketch the position of X. X, remember, is a point that is on longitude 50 degrees west. So let me draw the longitude first. Look at the longitude 50 degrees west, that is the longitude of X. So let me draw it. Look at the longitude 50 degrees west, and it is latitude is 40 degrees south. Look at 40 degrees south. Look at it, look at it, look at it highlighted. So I'll try to draw the latitude 40 degrees south. Let me see, assume it is this one. So that will be the position of X, where the latitude crosses the longitude. That will be the position of X. But the question says another point Y is due north of X. Due north of X qualify X to be on the same longitude 50 degrees west, because from X, if we are going to the Y, you take the northern direction. Northern direction means you are trying to reach the northern hemisphere. You are moving along the same longitude. So surely Y is on the same longitude as X, which is the longitude 50 degrees west. So that will be your Y. Y will be somewhere along the same longitude. So let me mark this as the latitude of Y and try to move ahead. But the distance between X and Y given in the question says Y is 40,000 or 4,000 kilometers away from it. So the distance between X and Y, meaning the length of that arc XY, is 4,000 kilometers. And that arc obtained an angle theta. So let us continue. So length of arc XY is given by the formula theta over 360 multiplied by 2 pi r. And there the distance is given of the XY. So let's substitute. We now have 4,000 kilometers equals to theta over 360 multiplied by 2 multiplied by 22 over 7 multiplied by 6,400. So what we are trying to get is the value of theta. After we get the theta, we use it to get the latitude of y. And the question asks us to find the latitude of y, but let's get the theta. It's the theta that we are going to use to find the latitude of y. So we continue making theta subject of the formula by cross multiplying, and we now have 4,000 multiplied by 360 multiplied by 7, everything divided by the product of 2 by 22 over 7 by 6,400. So multiplying numerator separately and denominator separately and dividing the two results give answer theta 35.8 degree. Look at y, as y is due north of x. Due north of x does not mean it's in the northern hemisphere. Only from x to go to y you follow the northern direction. So we use the value of theta. Remember, it says if the two are in the same hemisphere, we subtract to get the theta, and we subtract the lower latitude from the higher latitude. So depending on this theta, can we get 35.8 by subtracting something from 40 degrees south? Look at it. If yes, which means y is also in the southern hemisphere. But if you cannot get 35 by subtracting something from 40, which means y is in the northern hemisphere, it is addition that we're supposed to do. But I suspect we can subtract something from 40 to get 35.8, because 35.8 is smaller than 40, which means we can subtract latitude of y from latitude of x to get 35.8. So there I will now have the theta to be equals to latitude x minus latitude y. And there I substitute my theta to be 35.8 equals to the latitude of x is 40 minus latitude of y, which I want to find. So rearranging, I will now have latitude y to be equals to 40 minus 35.8. Their latitude y would now be equals to 4.2 degrees south. This is the latitude of y. Another example is says two cities K and L. Those two cities are on the equator and on longitude 60 degree east and 12 degree west respectively. The question asked here is to find the distance between K and L along the great cycle. The capital R given in the question is 6,400 kilometers and pi given in the question is 3.142. Solution to this problem: we try to sketch the position of K and the position of L on the Earth's surface. So this is the Earth's surface, this is our Earth. And the two cities K and L are on the equator. Remember, equator is a special latitude 0 degree. So 0 degree is our equator. Look at it. So we try to mark the position of K and the position of L. But K is on longitude 60 degrees east. Look at 60 degrees east highlighted. So I'll draw this longitude 60 degree east, something like this. Look at it. This is the longitude 60 degree east. So that will be the position of my K, where the equator crosses the longitude 60 degree east. That is the position of K. So next is to locate the position of CTL. The CTL is on longitude 12 degree west. So I'll try to draw longitude 12 degree west. Look at it, look at it, look at 12 degree west. That will be my longitude 12 degree west. And where the equator crosses that longitude will now be the position of CTL. So I continue. I have marked the position of K and L. So next is to attempt to find the distance between K and L along the great cycle. Our great cycle in this case is the equator. Look at the distance KL. It's represented by the length of arc. Distance KL will now be given by the formula theta over 360 multiplied by 2 pi r. So our theta is next to that we needed to find. The theta here is the angle subtended by the arc KL at the center of that equator. So to find this arc KL, we look at the longitudes of K and the longitude of L. The two longitudes are in the opposite direction, meaning one is east, the other one is west, if you can see it in the drawing. So there, to get the theta is nothing but the addition of the two longitudes. So theta will now be equals to 60, the longitude of K, plus 12, the longitude of L, because the two are in the opposite direction. So the addition of 60 and 12 give answer 72. That will be the value of theta that we need to use in this formula. So substituting, we will now have distance KL to be equals to 72 divided by 360 multiplied by 2 multiplied by 3.142, the value of pi given in the question, and multiplied by 6,400, the value of r given in the question. So simplifying this correctly will give answer KL to be equals to 8,043.52 kilometers. That will be the distance between CTK and CTL. And this is the end of this lesson. Let us now revise some of the things that we have learned in this lesson. In this lesson, you have learned that longitudes and the equator are referred to as a great cycle. You learned also in this lesson that the radius of all great cycles is the same thing as radius of the earth. You learned also in this lesson that the distance between any 2 points on the earth's surface is given by the length of arc between them. You have also learned in this lesson that the distance between any 2 points along a great cycle is given by the formula distance equals to theta over 360 multiplied by 2 pi capital letter R, where theta is the difference in latitude if the two are on the same longitude, or theta is the difference in longitude if the two are on the same equator, and capital letter R is the radius of the earth, and pi is a constant value usually given in the question.